Okay, chapter 6. So we're looking at the normal probability distribution, and we're talking about a normal curve. Now, a normal curve is bell-shaped, okay? It's symmetrical about this vertical line. Our population mean is right here at the tallest point, right in the middle, okay? The normal curve does not touch the horizontal axis, okay? And we go out standard deviations. This means 1 standard deviation above the mean, 2 standard deviations above the mean, 3 standard deviations above the mean, 1 standard deviation below the mean, 2 standard deviations below the mean, 3 standard deviations below the mean. Okay, so you've got your normal curve. We always go out 3 standard deviations. Okay, so let's look at this example. Use the normal curve below to find the values. Well, the first thing I'm asking you for is the population mean. Well, that's right here in the middle. That's going to be 18. Okay. Here I'm asking, what is the value that is 2 standard deviations below the mean? Well, here's our mean. I go down 2 standard deviations. I'm at 12. Now, what's 1 standard deviation above the mean? So here's the mean. I go up 1 standard deviation. I'm at 21. Now, what is the standard deviation? Well, if you notice, as I'm going from the mean and go up a standard deviation, I go up 3. Okay, we're going by 3s. That is the standard deviation. Okay? All right. Sorry. Okay, I tried to draw these with pens, so look at the normal curves below. Do these distributions have the same mean? Okay, and I tried to draw that. Yes, they should if we draw those correctly. All right, what is it? Well, it looks like they both have a mean right here centered at 10. So, yes, mu equals 10. All right. One of these curves corresponds to a normal curve with a standard deviation of 3 and the other to one with a standard deviation of 1. Which curve has which standard deviation? Okay, well, a standard deviation of 3 means more spread out. Well, if you notice, curve A is more spread out. Curve B is really tall. Everything's bunched up together. So that would mean that A goes with the standard deviation equal to 3, and graph B goes with the standard deviation that equals 1. All right? Now, this particular section, we're going to talk about the empirical rule, and I'm going to go through this because even though the book gives you this picture that we're making, they leave out the areas in the tails. So I want to talk about this. All right, 68% of the data is within 1 standard deviation. So I broke that up into 2 pieces. If there's 68%, that leaves 34% for each of those pieces. Okay? And then we have 95% of the data values lie 2 standard deviations away. So 95% lie from here all the way over to here. So we need to subtract out that 68 from the middle and then divide it into our 2 pieces. And I forgot my calculator, but if you do that, we get 13.5%. Okay? Then we have 99.7% of the data values will be within 3 standard deviations. So from here all the way over to here. So we're going to take that 99.5, subtract out the 95 in the middle, divide that by 2, and that tells me I've got 2.35%. 2.35%. Okay? That's where the book stops. We don't have 100% yet. We've got 99.7%. So there's some area left out in the tails. So I'm going to take 100 minus my 99.7, divide that by 2, And that leaves me with 0.15% in the tails. 0.15%. All right, now we're going to use this information, okay, to work an example. Assume that the heights of boys in a high school basketball tournament are normally distributed with mean 70 inches and standard deviation 2.5 inches. Draw the distribution. All right, so we're going to do our best to draw a normal curve. I should be using a pencil, but here we go. Okay, not so great, but that's all right. Okay, our mean right in the middle is a 70. And I know I'm going to go out 3 standard deviations on either side. My standard deviation is 2.5, so 70 plus 2.5 is 72.5. Plus another 2.5 is 75. Plus another 2.5 is 77.5. Going down, 70 minus 2.5 is 67.5. Minus 2.5 is 65. Minus 2.5 is 62.5. All right, so we drew our distribution. Now, what percentage of boys in the tournament would you expect to be taller than 72.5? So now we're looking at, to the right, is 72.5. So these 3 sections, okay, this had, what, 13.5%? Plus, and this little part here had 2.35%. Plus, and then this little part out here, 0.15%. Okay, which I believe is 16%. All right. What percentage of boys in the tournament would you expect to be between 65 and 72.5 inches tall? So now we want from here up to here, okay? So we want this section, and this section, okay? So I've got 34, 34, plus 13.5. So let's see. 68, 78, 81.5%. Hope I did that right in my head. 68, 78, 79, 81. Okay, good. All right, if there are 120 boys in the tournament, how many of them would you expect to be shorter than 65 inches? Well, first of all, we have to find the percent that's shorter than 65. So that's going to be the 2.35 plus the 0.15, so we get 2.5%. So now I need 2.5% of 120. So 2.5% as a decimal is 0.025, and I multiply that by 120. Okay, that's going to give you your answer. I apologize for not having my calculator with me at the moment. I could certainly work it off on the side, but I'm running out of time. Anyway, let me know if you have any questions.